Welcome everybody. This video is an introduction to curve printing with IceSL. Curve slicing is available from the latest beta version of IceSL, which you can download from the website right now. So let's suppose we would like to print this model here. If we use conventional planar slicing, the surface of the print will look like this. And as you can observe, it's not ideal because there's a lot of staircase effect here, 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 and here. From the front, you can also see it. However, we can enable curve slicing. To do that, we click on slicing here and this setting called enable curve slicing. When you click this setting, IceSL will show you a warning that tells you that this feature is still experimental and you should verify your G-code before printing anything. Now, after clicking on enable curve slicing, 3 other parameters will appear. We will not worry about them for the moment, and I will disable enable button curving. I will re-slice, and this is the result. So as you can see, the print has a much better surface quality because the layers are curved to follow the surface of the model. There's no longer the staircase effect. And seen from the front, you can see that the layers are deformed to follow the curvature of the mesh. Now let's suppose we would like to print another model, something like this. There's many curvatures, many angles in this model. Here, for example, is completely planar. Here there is an angle. And in the back part, there's another angle that is much bigger than this one. Okay. These two parameters, the first one called target curving angle and maximum curving angle, both of them specified in degrees, can control the output of the curving algorithm. The first one, target curving angle, is meant to be a parameter adapted to the shape that you would like to print. So here, for example, the target curving angle is meant to reflect how much the curving algorithm will follow the curvature of the model. Okay. The maximum curving angle is a setting to avoid collision between the part that is already printed and the extruder of the 3D printer. Why does this happen? Because the layers are no longer planar, so the extruder might collide with a layer that was already printed in curved slice. To show this, we can see this extruder here. As you can see, the cone of collision of this extruder is very big. So this part here might collide with the print that's already done. So this angle of collision is very, very, very low, around 10 to 15 degrees, while a printer like this has a cone that is much, much smaller. So no collision happens after this cone. And the angle of curving can be much greater, in between 40 and 45 degrees. So let's change this target curving angle to 15 and the maximum as well to 15. I will slice. Let's diminish a little bit the size. And let's slice. So this is the result. And as you can see, the layers are still curved to adapt to the shape. However, the surface in this part, in this inclination, still has the staircase effect because the target curving angle was very, very low, 15. So as I was saying, this should be adapted to the shape that we would like to print. So I would like to change this to 30 and the maximum curving angle to 35. I will reslice, and this is the result. Layers are still curved. They follow much better the surface, and the surface quality here is much, much better than the last one. However, on the back, because this inclination is much bigger than this one, the staircase effect can be seen here. Some printers might be able to have no collision at angles that are bigger than this. So I might change this to 60 and 65 and reslice. And this is the result. Still curve, and this surface on the back is also curved and no staircase effect. Let's go back to the model we used before. This one. We change this back to 30 and 35. Now, as we saw before, the surface is much better. There's no staircase effect, but if we look at the bottom of the print, we have this. It's still completely flat if we see it from the front, but aesthetically, the surface is not optimal. In order to improve this setting enables bottom curving, which also curves the bottom of the model and harmonizes it with the curving that happens on the top. Could be enabled to solve this. So let's try it. And now we have the same surface quality on the top, and in the bottom it's completely planar. And as you can see, the layers deform with respect to the planar bottom. Another use of this setting enable bottom curving can be seen with this model. If we disable it in this model and we slice, you can observe that the top is well curved, no staircase effect, but the bottom is not. There is the staircase effect here. So if we activate it and reslice, bottom curving will harmonize with the top curving and will produce a much, much better surface on top and the bottom. Now, it is very common to have models that need bottom curving to need also supports. This is one of those models that need supports. Curve slicing in IceSL integrates well with the support structure. So the interaction is actually well done, and we will try it here. We activate supports here, and we re-slice. Enable curve slicing is still active, and we can see the support structure. We might also observe that the support structure also deforms to be able to accommodate to the curved layers. And we can also see that if we do not show the supports. The bottom and the top are still curved. This combination between curved slicing and supported structure also work well with models as complex as this one. So I'm going to scale it back a little bit. And I will slice with supports activated and with top and bottom curving. And this is the result. Again, we can hide the supported structure and see that the bottom and top are well curved. This is the top surface and this is the bottom surface. So we hope you like this new feature of IceSL. You can use it now. Download the latest beta version.